So with example 1, we know the name of the line. Well, first of all, since it's a line, we will use the proper line notation. And then we'll use 2 points on that line, so we'll use S and T. You could have also named the line TS. The name of the segment, so now we'll use a segment notation. We can name it ST, or again we can name it TS. We just have to make sure that we use the endpoints and we use the proper notation above. Lastly, we want to find the length of the segment. Since we're talking about length, we drop the line above and we just write ST. The length will be 8.4 minus 3.2, which gives us 5.2. So the length of segment ST, which we write as ST, equals 5.2. Okay, this brings us to the idea of betweenness. Betweenness only occurs with three or more points are collinear. So when we have at least 3 or more points that are all collinear, we get 1 point in between the others. Remember, collinear means they all lie on the same line. For example, if I have this line that has A and C, and then B lies on the line as well in between A and C. If I had a line that had A and C but B was not on the line, then B is not considered to be in between A and C. So the characteristics are we have to have collinear points, and that allows the middle point to be between the other two. We need to know betweenness because that allows us to understand the segment addition postulate. This is your second postulate. And remember, because it's a postulate, we do not need to prove it. This postulate tells us that if B is between A and C, like we see above, then the length of AB plus the length of BC must equal the length of AC. Similarly, if we know that AB plus BC equals AC, then it must be the case that B is between A and C. So this works both ways. The one you're going to use most in this class is this first idea, that if we have 1 point in between two others, we can add the 2 smaller segments to equal the larger one. Which brings us to example 2. Given the segment you see on the screen, which we do have 3 collinear points, I want you to find the value of GH. Try this on your own first, and then resume the video when you're ready to check your solution. Okay, since this whole thing is 36, if this part is 21, then the remaining must be 36 minus 21, 15 units. And then we can double check because we realize that 21, which is the length of FG, plus 15, which is GH, will equal 36, which is the entire length FH. That works. Thus, GH equals 15. Congruent segments. We can have line segments that have the same shape or the same size. If they have the same measure, they're called congruent. Congruent means same shape and same size. So if line segment AB had the same length as line segment CD, then we would say that the segments are congruent to one another. You need to be particularly careful about notation here. There is a difference between talking about the length of a segment, which is line 1, and talking about the shape of a segment, which is line 2. When we talk about length, we use no lines above and we use an equal sign. When we talk about shape, we use the segment lines above and we use a congruency sign. And the way we notate this is we do little dash marks. So equal to,